So here is another question. So it is given that a bullet on entering a target with an initial velocity u loses u by n of its velocity after penetrating a distance s into the target. How much further will the bullet go? So let us try to draw a diagram. So here we have, let's say, we have a target made of a certain material. A bullet is fired from a gun, okay? It is fired from a gun, and here it penetrated a certain distance s into the target. Let's say up to this point. From here to here, it penetrated a distance s into the target. The initial velocity of the bullet is u. Here it is u, here is also u. The point where it started penetrating into the target, here also the initial velocity is u. After traveling a distance s inside the target, it lost u by n velocity. So here the velocity is u minus u by n. Okay, this is the final velocity here. So here you should write it down. Initial velocity is u, final velocity is equal to v. So this is the initial velocity u and the final velocity v. The distance, as it is traveling in a straight line path, so distance or displacement, so that is equals to s. Now here we can put the equation of motion v square minus u square is equal to 2as. Final velocity is given, u is given, initial velocity, distance s is given. We have to find the retardation. Here retardation, because the velocity is getting reduced, so obviously it is retardation. So you have to find a, the retardation or deceleration produced. So here we'll substitute the values. The final velocity v here is u minus u by n. So you have to substitute this. U minus u by n, or we can write it as u by n into n minus 1. In this way we can also write, okay, same thing, u by n into n minus 1. So we substitute v with the final velocity with u by n into n minus 1, okay, this whole square minus u square is equal to minus 2as. Why? Because it is retardation we are talking about. It is retardation. So that's why minus 2as. Then multiplying minus 1 on both sides, we get u square minus u by n into n minus 1 whole square is equal to 2as. Simply multiplying minus 1 on both sides. Then we have u square minus u square by n square to n minus 1 whole square is equal to 2as. That implies u square minus u square by n square minus 2n plus 1. Okay, that is equal to 2as. Okay, then we have, it is taking u square by n square common. Okay, u square by n square common, we have n square minus n square plus 2n minus 1. This is equal to 2as. Here n square minus n square gets cancelled, becomes u square by n square into 2n minus 1 is equal to 2as. Okay, so now here acceleration is equal to u square by n square into 2n minus 1 by 2s. This is the retardation, okay, negative acceleration or deceleration which is produced. Now it has been asked how much further will the bullet go. So obviously, as the target, it is producing some opposition, some obstruction, it will finally come to rest, losing all of its velocity. So let's say it further travels a distance x before it comes to rest. Okay, it further travels, let's say, a distance x up to this point. From here to here it travels a distance x before it finally comes to rest. So finally comes to rest means the final velocity is equal to 0. Here at this point, which was the final velocity in this case, that is u minus u by n into n minus 1, which was previously the final velocity for this journey, the x distance, that is the initial velocity. The initial velocity is u minus u by n, that is the new initial velocity. Okay, so again we'll be applying the same equation, v square minus u square is equal to 2as. Here we have the value of a with us because it has been given with the same deceleration or negative acceleration, how much further will go. So we'll be applying the same equation here, v square minus u square is equal to 2as. So here final velocity is 0 square minus u by n into n minus 1, which is the new initial velocity in this case, then negative acceleration, that's why minus 2a. Here the distance which is covering is x. So again, here don't put the value of a because the equation will get complicated. Just get the value of x, then we'll put the value of a. So that implies here minus u by n into n minus 1 whole square is equal to minus 2ax. So this becomes plus. That implies x is equal to u square by n square into n minus 1 whole square by 2a. That is the value of x. Okay, u square by n square into n minus 1 whole square by 2a. This is the value of x. This much distance it will penetrate. Now we can substitute this value of a here. Okay, we'll substitute this value of a here. So please be careful while doing it, because so now we will put this value of acceleration which we previously calculated here. So please be very careful when you are putting the value. So the value of the distance further which it travels before it comes to rest is equal to x is equal to u square into n minus 1 whole square by n square to 2 then u square into 2n minus 1 by n square into 2s. Okay, so now here n square gets cancelled, 2 gets cancelled, u square gets cancelled. Okay, this. Now we are left with this s goes to the top, so it becomes s n minus 1 whole square by 2n minus 1. This is the final penetration distance before it comes to rest. Finally, further which it travels this. Okay, so first the bullet was fired with an initial velocity u. It started penetrating from this point with the same velocity, initial velocity. It traveled a distance s. At this point, it lost u by n of the initial velocity. So here the final velocity was u minus u by n. From there we calculated this acceleration using this equation of motion, v square minus u square is equal to s. Then it was asked, from this point how much further it will go, how much more distance it will penetrate before it comes to rest. Obviously it will come to rest at some point, because the target, it is providing obstruction. Then the initial velocity for this case was this u minus u by n, final velocity was 0 because it will come to rest. So we use that, again the same equation of motion, we put the value and we got the result. So here, while putting the value of a here, you please be careful because a lot of terms will come into play. So just be careful about that. Okay.